Here's part 2 of your Chapter 4 study guide. Hot air balloon A rises y feet in x minutes. The equation representing its ascent is y equals 50x plus 5. So that's hot air balloon A right here, this equation. The graph shows the altitude and the descent of hot air balloon B. So we're looking at an equation and we're comparing it to a graph. Which hot air balloon begins at a higher altitude? The beginning is the B in the equation or the y-intercept. So you could see that hot air balloon A begins at a plus 5, so that's barely off the ground, and hot air balloon B begins at 500. So which one begins at a higher altitude? That's going to be balloon B. Which hot air balloon is moving at a greater rate? Rate is the same thing as slope. So hot air balloon A has a slope of 50. Hot air balloon B, we would have to figure out the slope doing rise over run. So I'm going to pick 2 good points, maybe here and here, and make a right triangle. And it looks like it's rising 50 and running back just a half. So that's 50. So that would mean 50 over a half, or if I went to the next even increment, let me go here to here. So rise 100 and run 1. So 100 to 1 compared to hot air balloon A, which is just 50. So again, it looks like B has a slope or a rate of 100. It's going to descend at a rate of negative 100 to 1, and that is going to, that would rise at a rate of 50 to 1, or also descend negative 50 to 1. So B for both of these would be the correct answer. For the next question, Kelly conducted an experiment to find the effect of a container's surface color on the cooling temperature of water. Kelly filled 2 containers of the same shape and size with the same volume of water. One container had a silver surface and the other had a dull black surface. The graph shows the temperature of the water in each container, y degrees Celsius, after x minutes. Part A. Find the initial water temperature of both containers. Explain what information is used to determine your answer. So, initial water temperature, that's the B in the equation, or the y-intercept. So let's look at the graph and let's find the y-intercept. That would be on the y-axis. So that's going to be right here on the graph. Now let's be careful to read the y-intercept. Both lines are beginning at the same temperature, and it does appear that the blocks are increasing by 5. So that means that's at 65 degrees for both containers. So explain what information you use to determine your answer. I would say I use the y-intercept. And you could elaborate on that if you wanted to. Part B, which container has the greater rate? So we should know what that means. Rate is the same as slope. So let's do rise over run to find the slope. That means we need to find some good lattice points to look at. So the dull black container, I might use this point right here, and we'd have to go back all the way to the beginning. Okay, so there's a right triangle, rise over run, goes by 5, so 5, 10, 15, 20. And then this also goes by 5. So 20 over 15. Is that right? 5, 10, 15, 20 over 15. Okay, and that would that could reduce to 4/3, which is like 1 1/3. And you can see it's descending, so that would make this a negative rate, negative 1/3. Let's look at container B and do the same process. Let's find good lattice points. Here's one. Boy, it looks like it's good on each slot there. So I'm going to rise and run. So that's going to rise 5 and run 5, which simplifies to 1. Our slope is negative. So negative 1. Okay, so which one is cooling at a faster rate? Cooling faster, a greater rate? I would say that the dull black container is cooling down faster. So we would say dull black, because this would be decreasing it at a faster rate. It's a little bit more than negative 1. Okay, the last question. A maintenance engineer turns on the relief valves of 2 pressure vessels in order to reduce the pressure within each vessel. The graph shows the change in vessel pressure P in pounds per square inch after X minutes. Which vessel has greater pressure initially? There's that word again. Initially is the initial value, or the y-intercept. So that's going to be the information we will use. So if I trail up vessel A, you can see that that begins at 5. So A begins at 5, and I would say I used the y-intercept. So vessel B then begins at 6. So B's initial value is 6. So which has the greater pressure initially? It's B has the greater pressure initially. And you could probably make yours look a lot neater than mine. So you would say B has the greater pressure initially, and I use the y-intercept to find the initial pressure. Part B. At which minute does the pressure of the 2 vessels measure the same amount? They intersect right there. So they would have the same amount where they intersect. They would be equal. So what value is that? It says at which minute are they the same? So which minute is that? If I look down, that looks like it's falling right between 4 and 6. So this would be at the 5-minute mark. The 2 vessels measure the same amount. Which vessel has the greater amount of pressure each minute? Explain what information you used. If we're looking for each minute, that would be the rate or the slope. So vessel A, I'd have to do those lattice points. Vessel A, I would go maybe from here. I'm trying to find good lattice points. I might have to go all the way back up to here and make that right triangle. Okay, so that's going to rise 3 and run 10. And for vessel B, let me change that to, let me do that in blue. Oh, B is nice. Rise 1, run 1. So this is for A, and for B is 1 over 1. Oh, wait a minute. This is going by 2's down here. So this would be 1 over 2. Okay, so which has, oops, sorry, both of these are negative slopes. Okay, so which has the greater amount of pressure each minute, 3/10 or 1/2? Okay, now let's answer the question. Which vessel releases the greater amount of pressure each minute? So 3/10 or 1/2. I would say that 1/2 is more, and if you look at the slope, vessel B is releasing more per minute. So So I would say the answer is vessel B. And the information I used is the slope. It has a steeper slope than A. 1/2 is going to be steeper than 3 out of 10. Again, yours could be neater than mine, but the point is the slope is steeper. It's going to be releasing the greater amount of pressure each minute.